Hi, let's predict survival on the Titanic. Let's use machine learning to create a model that predicts which passengers survived the Titanic shipwreck. In this document series, I am going to demonstrate how to train data set for machine learning competition called Titanic, which is hosted in Kaggle website. First of all, we need data sets to train. We can find it in Kaggle website. In this demonstration I'm using Jupyter Notebook on Anaconda Navigator. Once we launch Jupyter Notebook it will open in our web browser and display our file system. When we start to code some program we have to import necessary libraries. In here what we are going to do is coding to train our data set, but it is not a program. Therefore, we have to import necessary libraries. Pandas is a software library written for the Python programming language for data manipulation and analysis. It offers data structures and operations for manipulating. Seaborn is a Python data visualization library based on Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. SNS is the short term. Sklearn for machine learning and predictive modeling. Now let's start by loading the training set. After importing libraries, next thing is reading datasets. In here I'm using read_CSV inbuilt function for reading my .csv files. I have given data set names as a parameter of that function and created name for this functions. Two datasets are available as a training set and a test dataset. I'll be using the training set to build our predictive model, and the testing set to score it and generate an output file to submit on the Kaggle evaluation system. Now let's start by loading the training set. In here we can see, we have 891 rows and 12 columns. Pandas allows us to have a sneak peek at our data. The target variable is survived column. If survival equals 1 the passenger survived, otherwise he's dead. That is the variable I'm going to predict. The other variables describe passengers' details. We called them as features. Those features are listed in the below. Pandas allows to a look at high-level simple statistical description of the numerical features. This can be done using the following method. In the count variable there are only 714 data. That means 177 values are missing in the age column. For this problem we can fill null values using median age. We could also impute with the mean age but the median is more robust to outliers. Let's check the output. We can figure it out using some charts. In here I'm using gender feature for visualize percentage of survived and dead people. It looks like female passengers are more likely to survive. Now I'm going to plot same diagram based on mean value of the age. Correlate the survival with the age variable. By considering all above facts, we can validate that women survive more than men. Majority of passengers between 20 and 40. Young male tends to survive. Age does not have direct impact on the female survival. Now I'm going to use ticket fare of each person to see how it could impact the survival. Using above plot I realize that passengers who bought cheaper tickets are more likely to die. Let's see correlation of age, ticket fare and survival by combining them. The ticket fare is proportional to the size of the circles. From the x-axis, I have represented ages and fare is represented from the y-axis. We can observe different clusters. 1. Large green dots between x equals 20 and x equals 45, adults with the largest ticket fares. 2. Small red dots between x equals 10 and x equals 45, adults from lower classes on the boat. 3. Small green dots between x equals 0 and x equals 7. Below chart represents the correlation between ticket fare and class. Below chart represents the correlation between embarkation site, ticket fare and survival. Observations from above chart are: 1. Most of the tickets were gone through embarkation C. 2. Majority of tickets with highest price were sell from the embarkation C. 3. Same thing happened in embarkation but less in the embarkation Q. Now I'm going to do feature engineering. Before that let's see what is feature engineering. Feature engineering means building additional features out of existing data, which is often spread across multiple related tables. Feature engineering requires extracting the relevant information from the data and getting it into a single table which can then be used to train a machine learning model. For that, first of all I'm going to define a print function that asserts whether feature has been processed or not. Now let's load the data. First of all, I'm going to append the training set to the test set together. Before feature engineering, that is a best practice to prevent information leakage. That means I do feature engineering to train data set and then I'll add those variables to the test data set. In here 1309 is summation of the number of rows in the train and test data sets. Now let's create new feature called title using titles of each name of the passenger. For that we need to look at all the titles in name column. This function parses the names and extract the titles. Then, it maps the titles to categories of officer, royalty, Mr., Mrs., Miss, Master. Let's run and combine this, and check if there are any missing values in the title column. It reveals that there is one title value is missing in line 1305 regarding to these mentioned names. But nothing to worry about this, because this title was not included in the train dataset. Now we have title column and it contains the information. In previously we saw that there are 177 missing values in age column and now I'm going to fill them. But replacing them with the mean or the median age might not be the best solution, since the age may differ by groups and categories of passengers. To understand, let's group our data set by sex, title and passenger class and for each subset, compute the median age. To avoid data leakage from the test set, I fill in missing ages in the train using the train set and I fill in ages in the test set using values calculated from the train set as well. This data frame will help us impute missing age values based on different criteria. This median age column and S value can be different based on the sex, PC class and title put together. Let's create a function that fills in the missing age in combined based on these different attributes. Actually we don't need name column anymore. Therefore now I remove name column. Then I encode the title values using a dummy encoding. When processing fare column, simply we can replace missing values of the fare column by using mean value. When processing embarked column, there are only two missing values in embarked column and in here. I'm using most frequently used embarked values for filling those missing values. When processing cabin column, we don't have any cabin letter in the test set that is not present in the train set. This function replaces nan values with U for unknown. It then maps each cabin value to the first letter. Then it encodes the cabin values using dummy encoding again. Processing sex column. To process sex column, this function I replaces male to 1 and female to 2. Processing PC last column. In order to process ticket column, let's check how many different ticket prefixes we have. And let's perform processing. When processing family column, create a new column based on the size of the family. It is done under a realistic assumption, which is, when large families are grouped together, hence they are more likely to get rescued than people traveling alone. This function introduces 4 new features, which defines family sizes as singleton, small family and finally as a large family. Finally, we end up with all 67 features. In modeling, we use our knowledge of the passengers based on the features we created and then build a statistical model. There is a wide variety of models to use, from logistic regression to decision trees and more sophisticated ones such as random forests and gradient-boosted trees. We'll be using random forests. Random forests has proven a great efficiency in Kaggle competitions. What we have to do is 1. Break the combined data set in train set and test set. 2. Use the train set to build a predictive model. 3. Evaluate the model using the train set. 4. Test the model using the test set and generate. We'll have to reiterate on 2 and 3 until an acceptable evaluation score is achieved. Now it's time to import sklearn libraries. To evaluate my model, I'll be using a 5-fold cross-validation with the accuracy since it's the metric that the competition uses in the leaderboard. To do that, I'll define a small scoring function. Recovering the train set and the test set from the combined data set is an easy task using following code. Now it is feature selection. We've come up to more than 30 features so far. This number is quite large. When feature engineering is done, we usually tend to decrease the dimensionality by selecting the right number of features that capture the essential. In fact, feature selection comes with many benefits: decreasing redundancy among the data, speeds up the training process, reduces overfitting. Now let's look at the importance of each feature. There is a great importance linked with title Mr., age, fare, and sex. There is also an important correlation with the passenger ID. Let's now transform our train set and test set in a more compact dataset. Let's try different base models. Let's check the accuracy by using following models. 1. Logistic regression. 2. Logistic regression CV. 3. Random forest classifier. 4. Gradient boosting classifier. According to these CV scores, I may continue prediction with hyperparameter which has the highest CV score. Hyperparameters tuning. I will be using a random forest model. It may not be the best model for this task, but I'll show how to tune. This work can be applied to different models. Random forest are quite handy. They do, however, come with some parameters to tweak in order to get an optimal model for the prediction task. For this task I'll use the full train set. Now that the model is built by scanning several combinations of the hyperparameters, now let's generate an output file to submit on Kaggle. Finally, submit the submission.csv file to Kaggle.